Hey everyone, this is Judy Warner with Altium's On Track podcast. Welcome back. Our audience continues to grow and we thank you for joining us again. And I want to give a shout out to Stephen Newberry from LGS Innovations, who took away not marking his, or always marking his diodes with the K. And so many of you have chimed in and are help driving actually who we have on the show and the topics we discuss. So thanks so much for joining. If you would, please connect with me on LinkedIn or at Altium Judy on Twitter. And Altium is also on LinkedIn, Facebook, and Twitter. And remember, we're always on YouTube as well as on your favorite podcast apps. So thanks again for joining, and hold on to your hats because we're going to have a little bit of a history lesson tied in with today's best practices. So today our guest is Bil Herd, who is actually a figure of history, and he has a Wikipedia page that you will have to take a look at. So for those of you that are probably, 40s and above, might remember the Commodore personal computer. It was one of the first. I'll let Bill fill you in all the details, but I remember vividly when I was in my early 20s, my dad coming home with a Commodore 64, and it was all the rage, and he thought, the world is forever changed, and I'll never, ever use all the 64K that I possibly have. So, Bill, welcome, and we're so glad to have you and can't wait. We're going to tell some stories. You're going to give us some design wisdom. So thanks so much for joining us.
My pleasure. Actually, I do describe myself as a recovering Commodore engineer. That's probably the best way to. And the active recovery never stops. You just kind of keep trying to get better.
I'm sorry, but based on the background behind you, I'm not sure about your recovery.
Okay, I've relapsed a little bit. But Hackaday helped.
So, briefly tell us what are you working now as a consultant? Like your own entity? I forgot to clarify that with you.
Yeah, actually, I'm self-employed, so to speak. I owned an ISP for about 15 years, and it had 16 people, and we did all that, and then it ran its course, as ISPs do. And so I do a lot of networking and high-level architecture consultation, but I never forgot how to do hardware design. So actually, you caught me in the middle of doing an Altium project right now where we're going to a limited quantity, but I just went through all the steps, all the dirty little details, getting a PC board out. So it was kind of fun to still be able to do that.
I love the way you put it, dirty little details. There's a lot of those, right?
You get to be imaginative for a couple days, and then you spend the rest couple months paying for it by looking at each and every line item and every footprint and trying to catch where your brain was wrong, way back in the beginning.
Yeah. Well, so I also notice you have, as I've gotten to get acquainted with you a little bit, back in the days of Commodore and the early days actually of the personal computer business, the words nerds and hackers weren't really around, but seeing you sit there in a Hackaday shirt with that lab behind you, I would say you are the quintessential original geeker nerd. What do you have to say about that?
Well, we did call it home computers back then.
Okay,
the PC hadn't been invented yet.
Okay.
And I'll also mention I've never been to school for any of this. I was basically a high school dropout, and we ended up in the service and went back and almost got my degree. I owe them like a library book, or the money, $3.42 for a library book, and an English class where me and the teacher just couldn't make it work. So about 3 years later, they sent home my diploma with my sister, just going, here, he'll need this someday. So, I used to say I was self-taught, but what really happened was self-taught got me into a couple good places, and then the education really started, working around really smart, really brilliant people that's where I got then the education that made it so I could do a product from beginning to end.
Mm-hmm.
So, but no, I was fixing TVs. I had my TV repair license at the age of 17 in Indiana. And sometimes they'd answer the door and didn't want to let me in because I got long hair and I'm carrying tube caddies, and they're like, "How are you?" I'm like, "Van out front, TV repair." and pretty soon they're feeding me cookies when they see me like fix their TV set. So.
Right. Well, we will share the Bill's Wikipedia page, and there are some like awesome pictures of this long-haired hippie with his cut-off denims and bare feet.
Don't tease me about the shorts. It was 1980.
Hey, I'm sorry, but I wore shorts just like that. So
yeah.
So we will share that because there's a lot of history and fun and great pictures that I think you'll enjoy hearing. So tell us a little bit about how you got into the whole Commodore thing, and then we're going to dig in and give our listeners some really practical advice on those nitty-gritty details you talked about, and then we'll wrap up with some more fun stories. So just briefly give us an overview of Commodore and Hackaday.
Okay. If I back up just a little bit, I started at a digital scale company in Pennsylvania making instrumentation. So there I learned to do very accurate stuff with very good grounding. I understood analog and RF spectrum and all that. And it was all hand tape, right?
Yeah.
A guy named Terry Fisher, who I just got through working with again. So after 35 years, we're still doing it. And he was on Altium this time. And so when I got to Commodore, I had the background for how to make something expensive and work. And then you just take that and you just shake it and it comes out of your head because now you got to make it cheap. Cheap.
Yeah.
Yeah. And if people are mad at me these days because they said, "Oh, I have a 30-year-old Commodore and it just failed I'm like, it was designed to last 5 years. You should have put a switching supply. I would have put a dime more into it. I'd have been fired if I did, So I got my job almost by accident at Commodore. I mean, there's a whole story rare and go into it here. Let's just say I blew the interview like 3 times and still got hired. One not even taken in my resume. It's just so. So I got there and they didn't know what to do with me. And I read in a book that I was actually hired as a technician. They just knew they could use people like me. And then they sat me down. The guy was out named Benny Pruden, and they said, "Well, here, study all his software manuals." So now it's going to be a programmer. I could do 6502 programming. But for a disk drive, I'm like, that sounds like the most boring thing in the world, but sure. And then I walked into the hardware lab, and I saw what they were doing. They were splitting the bus for the video, which back then was I was doing it at home, and that's why I said I just built something at home where I actually don't wait till the vertical retrace time to write to RAM. And 2 weeks later, I was in charge of the project. The guy was leaving. They didn't have anybody else, so now I'm a hardware engineer. I'm a project leader at Commodore within a couple weeks.
Oh my gosh, it was like the Wild West, was it not?
Oh, absolutely, and loved. I brought a certain Animal House, to that because. We had lost a lot of talent. I mean, there was people like Chuck Peddle who designed the 6502. He's gone, but his cigar's burning in the ashtray. The chair's still warm, right? So you knew that these people had been there, but they're gone. And there's these kind of older, stogier guys and me. And pretty soon it became an environment where shoes became optional, So it did. We definitely made it into what we wanted to. And you have to do that when you work 20-hour days.
That's crazy. So you're sleeping in the office,
or
not sleeping.
My record was 11 days without leaving. I had an air mattress. I would actually hot bunk with a technician, so I would get something designed like 2 a.m, kick the air mattress, out, and they would build it for me, and I'd go catch an hour or two sleep, and then they'd come back and kick the air mattress and say it's built, So just taking showers out of the sink, things like that.
Nice.
Yeah.
Well, we'll talk more about some of your fun Commodore stories because I know we'll really want to dig into those a little bit more. But tell us also about your involvement with Hackaday.
It's actually interesting that I used to watch Ada Fruit's little Saturday night show, right?
Yeah, love that.
and they would do this thing where they'd give something away, and usually it was a product, and I didn't go for that as much because I could just their products are so cheap I could just buy one.
Right.
But one time they had been to the Open Hardware venue conference,
yeah,
and it was actually at MIT, I think. And they asked a question, and I went right to the webpage, found the answer because they were giving away the swag bag. I mean, here they're like. So I said, that I'll go for. So in the swag bag was some cool things, but one of them was it was like an Octopart, only it was somebody else's version of it.
Okay.
Well, they're owned by the people that own Hackaday. So I start talking with him. I ended up a beta tester, and the guy realized I just never shut up, that I'm always telling stories, right? And so pretty soon he puts me in touch with Mike, the head editor at Hackaday, and I'm doing the same to him, only in emails. And finally, he's like, all right, that's it. Write stuff or shut up. And so, and we came up with a video format because, it works for me. It works for my personality. And I am a high school dropout, which means my English ain't so good anyway. So the video works better for me.
Yeah, well, we will also share those for our listeners there. I've seen a few of them, and he is perfectly suited for that. So I'll share that as well for you. You want to be hackers and that. So let's dig into some immediate content that I hope will help engineers and PCB designers that are listening to us. You have told me how many EDA tools have you used over your career?
Yeah, I made it all up. Hardly any at all. No, it's had to be like 7, 8, or 9, depending on how you count them and to what degree. But yeah, going back to the 1980s when a workstation cost $50,000 or $100,000, and you couldn't get them as a home user or even as a small business.
Right.
And so no, we started it, we started with hand tape. And the cool thing with that is if you can do good hand tape, you can use a tool like a CAD and do more.
Right.
But you still have to be good to begin with, right?
Right.
You have to understand the principles. And nowadays it's more common for engineers to do their own PCB layout. But I'm still of that school that do what you do really well and use somebody when possible that does what he does as good as you. That's why I use a guy, like I said, Terry Fisher.
Right.
He's as good at and he knows when to ask me questions and I know when to shut up, right? So we have a good relationship for that kind of thing. And he started on, we started on Mentors, which actually we designed chips with, but he started on a system called a SciCards. And it was a card that plugged into the VAX. Well, when he'd start moving parts on the PC board, everybody's computers slowed down, right? These chip designers and stuff, because it's on the VM bus, it's taking the cycles directly. So they give Terry his actually he goes by Fish. They gave Fish his own VAX. So now he's got a $350,000 CAD system to lay out PC boards, and so that's the 1980s,
Yep.
And the Mentor. I hadn't really even seen a real mouse like we used till Suns came out. It had a scratch pad, so I actually grew my fingernail into a point, so that I had a built-in stylus on my index finger for. So yeah, so genetically modified, kind of like like the.
That's funny. So, with all of those changing of tools, which most people that I know that are designers, once they get proficient on a tool, they'd rather die than change tools because it can be such a painful process. So, tell us about
changing tools in general?
Changing tools. If you have to do it, what is the least painful path?
Well, management will always want you to do that right in the middle of a project. Right. And it's pretty key to try and not. We actually moved our hardware labs right in the middle of a project one time, too, just, kind of in the same. But if you're going to change programs, realize that they're just tools. And after you've changed a couple times, you start to learn, okay, I know how this play goes. And you do a couple of the same things. And you sometimes learn to really appreciate your old tool, and sometimes you learn that, hey, the new tool's better.
Right.
But they're no two the same, especially in CAD where there's so many complex things. So I think people picking up tools. I saw it a lot with Eagle, what they did, and they did an amazing thing for the maker industry and the home users. Even though I hate the program, I just if you're a professional, you just go, what? I have to drag the trace off the screen to hit the menu? This is like somebody put a GUI on a command line program. Well, guess what? Eagle is a GUI on a command line program, back in the old days. So, but the false attractiveness of something like Eagle was it did have huge libraries, right? And especially for boards, because I mean, these Arduino boards, I can't deal with the mechanics of them. They're not on the centers. I'm used to all that. But what you really have to come down to when you do a CAD system is realize you got to make your own parts at one time or another. So you might as well get proficient at it. And if you're using libraries, you might just be using somebody else's problems. So even if you do use somebody else's library, it's like you got to still vet the part, right?
Yeah.
So you just realize that you're going to have to make your own parts. And then there's things like BSDL importing and stuff. Like if you're doing a 250 pin FPGA, you don't want to hand do that either. So there are tools to help you avoid the mistakes. But almost all the errors I've ever made in CAD systems are related to the parts I've made. Yep. Where because I actually have data books here, not data sheets. A guy said, yeah, you use the word book, don't you? And while you're looking at the book making the part, I've done simple things that I'll never catch myself by having like D7 to D0 instead of D0 to D7.
Right.
Well, my eyes see what I think I want to see, and that's it. The mistake is in there until somebody else catches it. Yeah. So we used to always, that would be something is to have somebody else check your parts. And footprints are the same way I still think. So that's the first thing is realize you got to make your parts. And then I recommend you just sit down and trash a board. Try not to ruin your library in the process, because you can screw up libraries, right? But then throw that board away and start again, this time trying to obey every rule you know how. And actually, even if you don't produce the board, actually obey all the rules, look up every command you don't know that you actually need, and that's kind of how I start a new CAD system.
So for our audience, Bill sent me a few just notes for the point of our conversation here. Here is a note that he wrote. Starting a new CAD, do a couple of projects early on. Sort of what he's talking about right now. His first line is, open CAD, get overwhelmed, drink.
Yes, it'll be overwhelming.
Okay.
It just is. It's like my drill sergeant said when I went to basic. He said, we know it hurts, gentlemen. You don't have to tell us. And we're like, oh, well, I'll keep my pain to myself. And so it's the same thing. Oh, I'm supposed to be overwhelmed. Okay, let's so you open it again and you start looking for what you know. So there are some things you need to learn the quirks of up front. Like, how do you do a bus? Everybody does it slightly different. That nomenclature, whether it's curly braces, brackets, whatever, and A10 ... A0, it might be low to high, it might be either way, but you got to learn those things and interconnects, how to make sure that a part's really hooked up. One CAD system I was on was called Altiboard by National Instruments, and the DRC wasn't catching the fact that parts looked like they were hooked up and they weren't. Well, how do you catch that? So,
how do you catch that?
Yeah, so you gotta you go around jiggling your parts, and it's stupid, So good DRCs, and which Ben, when he looked over my shoulder to check my auto router from Hackaday, Ben Jordan, he gave me a compliment that I took, which was, oh, it's nice to see you have all your DRC errors fixed. Well, I'm old enough I don't remember fixing them, but I'm old enough that I know I would have fixed them. Because that's it. That's your last chance to catch that you have a net floating, even though you don't know it, whether it's a misspelling, even capitalization change, something like that. So yeah, you got to learn all those dirty details.
I was just talking to John Watson on this podcast about a week ago. We talked a lot about libraries and the same subject. It's like a theme that most headaches seem like they begin and end with the parts libraries, and even having a data sheet that's correct or hasn't changed in the last 5 minutes.
Yeah.
How do you address that?
Well, I still have data books. So, no, it is. It's still like going over it and over it, a couple of times and having somebody else look at. I'll still take a highlighter to a schematic sometimes, just to, if I feel I'm getting confused, out comes the highlighter to help me get more confused. But at the end, hopefully I get it straightened out.
That's funny. Okay, so I keep bumping things. Sorry about that. So
ask me about hidden nets.
Okay, go.
I hate them. Hidden nets are where somebody thought, let's show a dip package or something. And we know we are hooking it up to +5 in ground, so there's no point in cluttering the schematic with it. Well, my attitude is, how do you know it's hooked up to +5 in ground? Nowadays, it's not even +5 in ground. It's +3.3, 1.2, 1. So, whoever came up with that, they need to have something. I don't want to say bad happen to them. They need to miss a CES deadline or something themselves.
So it's an invitation for failure, is what you're saying.
Yeah, you can't check it. You make assumptions, and that's where problems start. So yeah.
Would you say that making assumptions is one of those easy pitfalls that for designers to fall into?
Yeah.
Right.
Yeah. Thinking SOIC is a size. It's not, there can be wide bodies, skinny bodies. And it's like, oh, but the picture looks like, no, you better learn one of the things you have to learn with new CAD package is how to measure things. And you need to do that, and then look to see, it's 0.43 inches or, and one time I almost missed the fact that the lead pitch was 0.5 instead of 0.75. That wouldn't have fit. When you try and solder
that would have
part
been
down.
Instant failure.
Yeah.
You made a comment about assembly drawings being readable. What did you mean by that?
As parts got smaller, the silkscreen no longer, it's not as important because of assembly techniques. But if you still want to measure, you can't get that little silk screen anywhere near the part sometimes.
Right.
So you end up with an assembly drawing where you had to put all these silk screens where you now want them inside the outlines and all that. So it's like you can't use the silk screen for an assembly drawing like the old days. You have to do a whole new one if you want to be able to find the part. So, but now these days, what I do when I'm working on a really dense board troubleshooting, I actually keep the CAD open and I do, jump to component and find it that way. I mean, it really is faster to use technology sometimes.
Sometimes.
At least I don't hand etch my boards anymore.
Yeah.
Remember that in the 70s?
I always say, because I was in the bare board industry for years, sales and marketing wise, and, we would take people walk through and do surveys. Plus, I actually worked on the shop floor for a short period of time. Like, I'm going to die of heavy metal exposure, man. The chemicals we had in there. I remember walking into plating room at the first board shop I worked into, and my skin just burning. Yes, burning. Yeah. Just poor ventilation, and there was sulfuric acid in there.
And you I'm told you can't have plating or PC board manufacture in New Jersey. That they've just kind of made it so you can't do that.
Well, so there's that. I mean, yeah. So there's a little bit of toxicity going on in the chemicals.
Right. And at Commodore, we made the ultimate printed wiring board, printed circuit board, right? Which is a chip. It's just really, really small. And we polluted the groundwater, and you can look this up. But we had to buy dedicated lines for like 11 neighbors, and then we had those golf course sprinklers in the back aerating the groundwater. Well, my first day there, I mean, they're just literally spraying it in the air, hoping the VOCs evaporate, right?
Oh my gosh.
I parked too close my first day there, and I come out and my car's covered with this sticky stuff, right? And not only that, I had parked under a tree, so now the leaves are stuck to my windshield with this. And you try and peel them off, they just break, and it's like, and they're like, "Oh yeah, dude, don't park there, man. that's in the water."
Like I said, it was the Wild West days. I mean,
still a super fun site, I'm told.
I bet. Like, it's frightening. It's frightening. I'm glad we've gotten our act together a little bit environmentally.
A little bit better, yeah.
Oh my gosh, because literally we could all die from those toxic. Yeah,
I remember the day my dad brought home mercury to play with. Jar of mercury. Yeah.
I remember my neighbor was an engineer. He brought home mercury to play with, and we'd roll it around on our hands or whatever. Crazy. Right. Forget about playing with it, putting it in your teeth. We would here, pour it in my hand. Let's roll it around. Isn't that cool?
Yeah, and you put it back in the jar, and it's never quite as full as you started, right? Because you're leaving a certain amount on the floor.
Like I said, good memories, but we might die young, just saying.
Yeah.
So when you start a new CAD program, do you just jump in and start designing? How do you take that on? If you're going to take on a new CAD, what sort of the way you approach it?
Well, as I said, I go in knowing I'm going to lose I do a trash board. Just it's all about just hooking some stuff up, knowing that you're making mistakes. And then I try and do something more real and try and really obey the rules. And that's where it starts to, and there's also at that time, that's how you're learning to connect from page to page, because every CAD system's slightly different. But it's kind of like how you think. You drop a part, you try and put a wire on it, and the kind of mistakes you'll make is not having a clear way of knowing how you want to do all the resistor values in the world, right? Do you make a part for each resistor value, or do you use a generic part and assign the values? And those are things you just have to figure out yourself on each CAD system, I think.
So, I mean, I honestly don't know how it's done. I have lots of compassion for my engineering friends who are also laying out boards, who really got no serious formal training in PCB design, but alas, they are laying out boards. And then they get thrown a new tool. So do you just hop on it and just start? Yeah, just hop in, just jump in and swim.
Remember, it's a tool too, and they have some really great tools like things that will help you plot RF noise on a ground plane or thermal or something. But at the end of the day, that's not necessarily real life. It's a tool. So it's an opinion. It might be a faster, better, more colorful opinion than we used to get with an old thermal probe. But you just got to kind of try it. And if you work around people who can look over your shoulder, they'll save you a lot of time, especially hotkeys and stuff like that.
Yeah.
And that's probably one of my pet peeves is I don't like having to rely on hotkeys, and that was even before I lost a finger, So now some of the hotkey combinations are literally beyond this old man's ability to do, without using my nose and stuff.
How did you lose a finger?
I tore it off.
Dare I ask?
I just caught my ring on something, and I stepped 8 inches off something, and it stripped it off the bone. We have pictures on the web of that also.
Oh, okay.
But I used to work at a trauma department, and I've flown with 103rd Combat Medics. I've been captain of a rescue squad. So I look down, and I just go, I know where I'm going today. I didn't even tell my wife, right? I figured she's away at a quilting bee. It's just, go have a good day. You come home the next day. I said, lost a finger. And, she got mad at me. She got mad at me for not telling her. I mean,
I would get mad at you too, just saying. Oh, gee, how's the quilt look? Good. Yeah. What'd you do? I just lost my finger.
Yeah. Well, I had my son actually look at it, and we took pictures. By the way, I had to wait half an hour for an ambulance, and being a former ambulance guy, that was just insult on top of injury, literally. But I wanted him to think of it clinically and not be, freaked out by it. So we took pictures and stuff like that. And then I told him, I said, well, don't tell your mother, well, but I'm going to, leave with these ambulance people now, and I'll be home probably tomorrow because I know, how things work. And he comes running to the door and he goes, Dad, what's the key to unlock the Xbox? I'm like, okay, you're going to be fine by yourself. First time he's by himself.
Oh my God.
He's thinking about the Xbox. So, all right.
Oh my gosh, you crack me up. What else do you want to talk about relative to CAD tools? I'm looking at my notes here. You're talking about something. You talked about the buses and nomenclature, index-based. Hidden edge, you said you'd hate those. So what else did we not cover?
I think the main thing is just how productive can you be? How well is it designed? And I was impressed by early OrCAD, which came out at like $4.99 in the 80s. And we were like, whoa. I mean, it's like that old monochrome, now there's PCs, right? Late 80s.
Right.
And the things you can do where if you copy a bunch of address lines, you can tell it when I paste it, auto increment all those address lines as if I was continuing to do them. So if I grab A0 to 7 and I paste it, now 8 to 15 is done for me. Well, you can fly. When somebody has thought of things like that to do, you can go real, and it has to be controllable. Sometimes you go, no, I really wanted A0 to 7, but there's tools like that can really make it so, just the ability to double click and there's a new segment just like the one above it.
Right.
Tools like that are real important to me. Where I've just spent too many hours drawing in each line by hand.
Yeah. I love since I've been here at Altium, one of my fun parts of my job has been to help connect our developers with hardworking designers where they can say, do it this way. We don't work that way. It's really nice when CAD tools will actually get together with the guys that are and just watch them work and go, because again, it's easy for developers, even if they've laid out boards, to make assumptions, right? So I really love that when tool manufacturers actually take it into consideration, and I love that we're doing that more and more these days. BOM distributor integration.
That's probably the one thing we didn't have in the old days, BOM integration, where and even picking the footprints, we had a 3-ring binder of IPC footprints, and so that was always a step where errors could occur. I'm thinking this way, PCB designers thinking that way, wrong footprint gets in there. But then even now, we can, with Altium, for example, you see the part as it's at DigiKey or Arrow, and you can make an attempt to select the part. Now, sounds great, but you end up getting into trouble when you go, oh wow, now I have to redo it for reels, for the auto insert. I still call it auto insertion for the pick and place.
Right.
Or guess what? The stock status isn't quite what you thought it is. There's a delay in there, and so now you still have to. I think in my world, I still do a final BOM as a spreadsheet, literally. But I get a lot closer in the tool. In the old days, we were using microfiche if you didn't have the data book, right? So nowadays it's integrated. So again, have to be careful. It's a tool, right? It won't do your work for you, right?
Right.
And that's the thing.
Well, usually, go ahead.
Well, I was just going to say, one of the, I've worked with also like CAD and KiCad, however they pronounce it.
Yeah, I know. I never know how to say it either.
Yeah, and it was good in that you could add modules to it. It was bad in that you could add modules to it. I kind of wanted already the 3D viewer working, for me to play with it and stuff like that. I'm really impressed with Proteus instead of Eagle for that low end market, not up here where Altium is, but that's when I was shooting little 2-inch by 2-inch boards for Hackaday, and I'm doing a complete design every month and doing a video, and so I design it and it gets a minute of video time, right, and then I throw it away and just start on the next one. So it's called Aries, and unfortunately the other one is ISIS. Nobody likes that name anymore, but that's the product name, and they have an amazing auto router in there that'll get you a good completion. Whereas if you've ever tried Eagle, it's like, why'd I even try the auto router? That turns out to be and they singled out the maker market. By including our Arduino-ish and ATmega parts in simulation and firmware simulation. So now you can simulate it as if you've written the code. You don't even need to build the board to see if it works.
Oh, that's cool.
And that's a cool feature. And we didn't talk about simulation. Almost all CAD tools these days do include SPICE of some sort.
Yeah.
Right, or a SPICE portal or something like that. And that's useful if you're down in the analog stuff especially. Again, still just a tool. I've seen SPICE lie horribly to you, and you think it's going to work, and it's really an artifact of 0 volts or something like that.
Well, there's a lot of talk these days about, because so many really capable designers like you and like many people I know have learned this over a lifetime, right? So if you're a new designer, where are you going to onboard that outside of just one-on-one mentoring? Like, any clues?
There's some good YouTubes out there, but
Okay.
I haven't found where you can. One, I don't have the attention span to watch somebody else work for 5 hours to pick up a couple tips, right?
Right.
So it's in the YouTubers showing you what they want to show you. But the best way is literally to be near somebody that's really good at it. Unfortunately, that's the best way. And it's almost always like people almost pair off in engineering where one guy's learning from another, even if they swap roles later that day because he's better at something else. Mm-hmm. That's just kind of the way it ends up going.
Yep. So I think what you're saying is find a mentor if you're not really good at it, right? And vice versa, and mentor others. I mean, it's...
Yeah. Yep.
Okay.
So ask me about the wire on each and every C128 board.
Okay. Oh, yeah. Actually, Ben Jordan snuck that to me. So let's go into war stories a little bit, and let's talk about the wire. I'll get a screenshot of this. I think, Ben, or do you have it?
There might be a lid on here.
That's so cool. Okay,
look how big this is. This is how.
Oh my gosh. Okay, so for those of you that are listening to this on the Straight Up podcast, you need to go to this portion and look at the YouTube just to see this giant board that he's pulling out of the Commodore 128, and look at the keyboard.
This is what we call a barn door stop. It's too big to be a regular door stop. And that keyboard I designed by looking down at my VT220. And I said, hey, it works for me. It'll work for future users too. So,
all right, let's see that board.
I'll hold it up to the microphone for users at home, right?
Okay.
Listening at home. but there is a wire on each and every. We made 5.7 million of these, more than the Apple II.
Okay, wait. Before you go into the wire story, give us the stats on Commodore 64 and went towards it, and compare that to the Apple, because I thought that was really interesting.
Yeah, and actually, I narrated a video by a company called Junk Food about called the 8-bit generation, and I learned some things. Our version of history wasn't quite as clean cut as to who was the first and the best computer company out there.
Okay.
So I'll give a little props there. But we often said, Apple's just using our parts, because we made the 6502. Well, that's the processor they used, but we made the chip, right? So we, in our minds, so Apple did come out, and they were first to get a floppy drive and some color early on, but then we come whooshing by them with the Commodore 64. Whereas they sold 5 million of the Apple II that you're always seeing on every show about the 80s, right?
Right.
You see a show about Silicon Valley. We created the home computer. I don't agree. Sorry, I'm from Commodore. I am a competitor, and we made 27 million. Not
wow.
Commodore 64s. We had all 64K. We had these cool color chips and sound chips that they didn't have. And we could do animation because we had these things called sprites, except Sprite was trademarked by Texas Instruments, so we had to call them movable object blocks, but everybody called them sprites. And so you could write a game, right, and the blocks are moving themselves around. You're not having to rewrite that whole screen and everything. So it was an amazing computer. So, and we called it the Apple Killer because we actually stopped talking about Apple after the
Apple
64.
Killer.
Yeah. Then my boss wanted to kill Sinclair. Remember the Timex Sinclairs?
I don't.
They're little tiny door stops. Now, I actually did use one of those for a door stop, and then the marketing department saw that. And so suddenly every door in marketing has a Sinclair holding it open.
That's so funny. I don't even remember that one, which I'm kind of surprised. I was kind of tuned in at that time, but not that tuned in, I guess.
It was a $50 computer. And actually so it actually, when the BASIC ran, the screen would go to crap because it couldn't share the bus. Remember, I talked about that earlier. And then they came out with a color one, and it was cheap. I mean, the Commodore 64 was $299. By the way, the Apple II was like $1,500, $1,700, and we're $299. And then we did something like we lowered the price $100 if you send us your old computer. So people were buying Sinclairs for $59 or $49, sending them to us to save $50. And that's of course $50, $19, $80, right? So
yeah, right.
But so this was his. If you can see it through the microphone here, this was the one of the family that we called Ted, and this is basically the Raspberry Pi of the day. It's all in there. The one chip does the video and the sound, and there's a processor. And the video sound chip runs all the DRAM and does all the crazy interfaces to the keyboard. So it's literally like very close to a single chip board, even though there was 9 in the original, 9 chips. Yeah, you cracked open an IBM PC and there was 280, something like that.
That's crazy.
And even the 128, as big as that was, it's couple tens of chips in there. So and then Jack Trammell unfortunately left Commodore, and this product I was showing, this TED thing, without him there to drive the vision, that product kind of failed. And we even had a talking version. We had snagged the guys from TI Speak and Spell, which was a big thing in the 80s. And we had them working at Commodore. So we had a talking version of a computer with a desktop that Apple will tell you later they invented the desktop. Well, no, the guys at Park invented it. But we had one. It's just our founder left, and it floundered without the founder.
Crazy. Okay, show us the wire.
Okay, so then the 128. So what happened was I had gone to a CES show, and by the way, CES shows drove everything for us, Consumer Electronics Show, mostly because if you ask them if they'll move it a day so you can hit your schedule, they'll say no. So the CES show is a scheduled date you cannot miss. You can't miss it by 5 minutes. You can't miss it by a day. And so we decided, and by we I mean the engineers, we didn't even really tell management about the C128 till it was too late. And then we would do things to it, like I added a Z80 processor, so it became it's Commodore 64 compatible, so suddenly nobody's going to complain at me because there's no software, can run all the old software. But then it turns out the Z80 cartridge didn't work very well on the Commodore 64, so I just put the Z80 right in the board. And after the PC board rev was done, I said, oh, by the way, I added a Z80. They knew they couldn't tell me to take it out now or we'll miss CES.
Right.
So we just, and then pretty soon the guy would be, I had a great idea to leave the Z80 in there, and you're like, cool, go tell marketing. Take a doorstop with you, right? So one of the things we did is, even as we're ready for the CES show it was January 6th that year, I think, we're already getting ready for FCC. So we're working on the final production, and that's all in 5 months. I started this near August. And we had 5 or 6 custom ICs that needed to be done. And so again, that was our wheelhouse, was this is custom, this is custom, this is custom, that one of the other ones in here. And we're going like the wind, right? Well, right near the end, the Z80 stopped working reliably. it wouldn't boot CP/M 20% of the time. And me and my boss were fighting. It's bound to happen, right? He'd already gotten his bonus, I think. I think the incentive to let me go around barefooted was like wearing thin, right? But I lost my train of thought. That almost never happens when you get old.
You fought?
Oh, I was fighting with the boss. And he said, fine, I'll give it to somebody else to fix that problem. I said, fine, I'll take a shower and go home and get a nap, right? So for a week, I mean, I had a great week, right? I caught up on my hygiene, you know, I won't tell you some of the other things you do when you're full of testosterone when you're young. But he comes to my office Friday, and in my mind, he puffed on his cigar. You could still smoke in the office back then. I don't know if he had a cigar that day, but that's my memory. And he goes, fix it or you're fired. Oh, sure, I can do that. You ready now for me to rejoin the workforce? Absolutely. I'm clean. You know, I get along with people. And I just happened to luck out where the oscilloscopes of the day weren't like the Tektronix MSO scopes like I got back here and stuff. I had to turn it up real bright, and then I would stare at it and then turn and look at a wall, and I would see the reverse image, and I go, there's a glitch right there. And I'm pointing it to somebody who can't see it because he hasn't burned his retina staring into the, and they think I'm freaking nuts. But I'm like, it's right there. And I was right. There was a glitch on this A10 line when the Z80 was the processor. But when the 6502 was the processor, there's no glitch. I mean, it's right around when the DRAMs were doing something. So it comes down to understanding how a signal propagates down, and this is part of PC board layout, right? And I liken it to when the 6502 was driving the length of the line, it drove it all the way to the end like playing a flute correctly. But when the Z80 drove it from an extension down the line, it was like blowing into one of the holes on a flute, and it's kind of not tuned. Wow. And so I got a standing wave where the wave's going back and forth and bouncing into itself. And it just happened to do it on A10 at the wrong time. And I caught it on the scope in an hour. And of course, nobody believes me, right? So, and the way I made it work was I took that wire that I showed you. That's redundant. There's already a trace on the PC board. Uh-huh. I just soldered this again. So now it's actually a loop, right? It can't bounce off the end.
It had a return path. Okay.
Yeah, or propagates like this, but either way, it's not a standing wave anymore at a certain spot, and it just happened to be that spot was the multiplexer for the DRAMs, and they're thinking I'm nuts, right? Because not only do I fix it in an hour, I fixed it with a wire. So we ran 10,000 units that weekend to prove that Herd's gone off the deep end, and we got 100% pass rate on it. It actually fixed the problem.
That's crazy.
So now the wire drives me nuts because there's 5.7 million wires out there. And people say, why didn't you just change the PC board? And it's like, because actually I found it this time, if there were no tools, right, to do anything, if I changed the PC board, I might have moved a glitch to somewhere I can't find. Right. So the devil,
Yeah,
and so that's how it ended up going out.
That's crazy. And from, by the way, having a background in EMS, for an EMS provider to have to put a wire on 5 million boards, that's crazy. Nobody would do that today, but it's cool.
And we called it post-solder assembly, and it's horribly expensive. You figure that's $5.7 million, because it probably costs $1. The wire's a penny and 99 cents to put it on there. So, and we just hate that. So there was one other fun issue with the schedule of the 128.
Okay.
At one point, and see, we didn't have real deep analyzers and stuff. So when the processor goes flying off the tracks because the memory's corrupted, you'd go, well, when in the last 2 minutes or 2 million cycles did the corruption occur? Because the analyzer's not going to catch it unless you're so lucky, right? So, but one of the things I noticed is it would corrupt in the video memory, and video memory is being scanned 15,000 times, 60 cycles a second. And so I took a light pin and I put it on this spot on the screen right where the corruption would occur, and I set my analyzer. So as soon as the spot on the screen occurred, the light pin triggered my analyzer. And it's actually a Commodore light pin. I still have it. It was actually plugged into the joystick port of the system I'm troubleshooting.
That's funny.
And it turns out it was called ground lift, and you're probably familiar with that. There was a stub of a little over an eighth of an inch on the ground pin of a DRAM multiplexer, and its inductance mixed with the capacitance meant it could come off of ground when you went to switch a whole bunch of ones. When you went to switch a whole bunch of zeros to a one, except for one, that other one became a one also. It just drug everything with it.
Got it.
And also took literally another little piece of wire, fixed it, and then I yelled at Fish to fix that one. I made him fix. But the only way we could catch it, in that case, is I used a light pin to catch this little 1/8 inch piece of trace that was just playing with me.
Well, you know what I love about these stories, Bill, is that I think it's lovely to tell them and show people what a Wild West it was and how we solved, like people like you solve things really simply, because now we sit on all these really complex tools and really we stand on the shoulders of people like you, right, who were innovating back in a day where we did not have the complexity of tools or things. And it's easy to take those things for granted now because so much can just run in the background and so I think it's fascinating to hear these really like these MacGyver ways that you figured out how to fix these. Well, you're like the original PCB design MacGyver dude.
So one other quick story. It goes right to that about the tools and the software simulations and things. And it's the day I knew I was working in the right place. And this isn't my story. This is actually the chip designer stories for the TED, for that thing I showed you. They had design rule checks when they laid out ICs that told them if two things got too close to each other. But they didn't have an electrical rule check to tell them if it's supposed to be shorted together or not. So they turned a corner. They had like A7, A8, and A9 cut right across the other two address lines. It shorted them out. And they had no way to do that, check that, unless they hand looked at every plot of every layer of what made up an integrated circuit. Well, they meanwhile cost $250,000 to do another run.
Wow.
So what they did, I'm in the hardware lab, and the guy goes, okay, turn on the microscope light. Okay, turn it off. Good, we're in NTSC mode. And I turn and I look and I'm like, did you just flip the status of a register with photons while looking at it under the microscope? And he goes, yeah. Mm-hmm. And he go back. I'm like, oh, I am in the right place. Oh, this is where I want to be.
Super cool, right?
Yeah. And they didn't have the tools that told them if what was on the schematics, what made it onto the chip. It was all
amazing.
Hand checked.
That's fun.
So, and they would spend 5 months, with a ruler, actually called a scale, checking the plot. That's the only way they could do it.
That's amazing. Well, thank you for sharing this. Unfortunately, we are running out of time, but thank you so much for sharing your history and your ingenuity and the stories of Commodore and giving our listeners really some practical ways of just jumping into a new tool if they have to, right? Nobody likes change, but I'm sure you would attest to that overall it's probably helped you become a better designer to go ahead and jump in. And you could probably jump into a new tool easily now. It probably doesn't freak you out as much as it used to.
If you know you're going to be overwhelmed, then you're right on schedule when you get overwhelmed.
Right.
And then you just go back into it and bite it. And, how do you eat an elephant? A bite at a time?
Yeah.
The same thing. With
just acceptance that it's going to be frustrating and this is the cycle.
Screw it up and then fix it. And then, just don't ruin your libraries in the process.
Okay. Well, some good wisdom. So thank you again, Bill, for your time. It's been a delight to hear about everything. And this, by the way, best background. Those of you who are listening, you really need to go look at the YouTube version of this because his lab looks like you'd all want to go live in it, man. It looks like there's everything in there. It's awesome. What's up with the penguin, by the way? There's a penguin. It looks like it's standing on your shoulders right now. There's a penguin on the telly. It used to be on top of the oscilloscope, but now it's just with the oscilloscope. That's a Monty Python penguin joke. That's from our era, right? See, totally.
There's a penguin on the telly. Yep.
That is so funny. Okay, well, thank you again for joining myself and Bil Herd today on Altium's On Track podcast. I'll make ssure to share all of his colorful links and Wikipedia and videos from Hackaday. And thanks for joining us again. We'll see you next time. Until then, remember to always stay on track.